Okay, let's do this. I think this will be the final video. It's going to cover pointers to pointers, and so I'm actually not going to talk about the picture in the bottom right. I'm going to focus on this example at the beginning, and then we'll work our way up to the picture on the right. But the idea is, just as we have here, we can have a pointer to a pointer. So we've got an integer x1, another integer x2, we have a pointer to an integer y1, and we're having it point to the address of x1, and a pointer to an integer y2, and we're having it point to the address of y2. And we've got a pointer to a pointer, which means that z is pointing at y1, which in turn is pointing at x1. So let's make sure I haven't made a mistake. Let's see. So good, so that compiles. And now we can add our print statements. And what I'd like to do is the same sort of table that I did earlier showing what all the values are and all the addresses are. So x1 is at %p and the value of x is, and of course, and I kind of slipped this through in a previous video, I know what the value of x is. I know that the value of x1, sorry, is an integer because we've declared it of type int. And so I'm putting %d. But when I get to y1, I know the value of y1 is going to be a pointer, so I got to switch that to %p. And if you get it wrong, the compiler will give you a warning and tell you you got it wrong. So that's good. The compiler's helping you. Okay, so now, wow, I got it wrong a lot. Looks like I was missing. I made this exact mistake earlier. Was this in the previous video? I forgot the terminating string. I think I made the same mistake in class too. Okay, and so this one says, this is not good. More conversion than data arguments. Indeed it is. Okay, so it's saying that I needed to, if I want to know the address of each of these, I needed to do that. Whoops. So for each of these, we're saying x1 is at, and we're taking the address of each, and then we're saying what the value is. So, yep, whoops. I don't think I'll restart the video over this. Maybe if I make more mistakes, I'll restart it. Uh-oh. We're continuing to have problems. Did I not save? Ah, look at that. Okay, good. So now, let's do the same thing where we make the table. And we'll have the name that we use, its address, and its value. And so the name we use is x1, its address is 0x, and again I'll just put the BEC, I'll truncate everything that goes before that BEC, and its value is 10. x2 is at 0xBE8, its value is 20. y1 is at 0xBE0, and its value is 0xBEC. Well, that makes good sense because we want y1 to point to x1, and x1's at BEC. And y2 is at 0xBD8, and it points at 0xBE8. Very good. And then z is at 0xBD0, and it points at 0xBE0. So that's all fine. Z points at y1, y1 points at x1, and x1 is 10. So the very first thing we could do is we could say star star z equals that. And that would dereference z twice, and we should get 10. Because the first dereference would be a pointer. And the value of that pointer, of the first dereference, would be BEC. So the value of what's, if we dereference this once, we'd say we'll go to what it points to, y1, dereference it, and it gets BEC. So remember I said this, that if you're doing the dereference, you say step 1, dereference, is dereference of pointer P. You say, what does P point to? Answer some address, like 0xBE0 in this case, and then what is the value of what P points to? Or in fact, let me just put of 0xBE0, and the value of 0xBE0 is another pointer, which is 0xBEC. And that's what we got. So then we can also view it like this, where we're now saying we'll dereference Z, and that will get us the value at Y, which is BEC, and we can say we'll dereference it again, and that would give us 10. So that might be some way to think about the double dereference operator, is that you're doing it once, and that would take you from Z to Y, and you do it again, and it will get you the value of what Z to Y1, and you do it again, that will get you the value of what Y1 points to. Okay, so let's make this a little harder. So, you know, if Z all of a sudden points at Y2, and if we say that the value of what Y2 points to should become 21, then if we print X2, the value of Y2 and the value of Z, then we should get 21 for all of these, because they're all going to the same memory location. They're all going to where X2 is, which is BE8, and giving a value of 20. Y2 does it directly, and then Z goes through Y2 to get to the same thing, which in this case, this changed to be 21. Okay, that's probably enough for just kind of the mechanics of how pointers to pointers work. And so now I want to talk more about how it could be useful. So let's do pointer to strings. And so if we wanted to, we could have a series of strings like S1 is hello, and S2 is world, and S3 could be Hank. Actually, let's make that be S4. And S5 could be Childs. And of course, for all these arrays, I've added an extra character for the null character. And then we could make a list. And so we'll do this. We'll use a malloc, I guess. And so now we're allocating 5 character pointers. So let's just look at this. This is the size of a pointer is 8 bytes, so this is returning 40 bytes. And we have 5 pointers. And we're going to set list 0 to point to S1, list 1 to point to S2, and so on. So, of course, we've learned before that every array, like S1, is itself a pointer. And so now we're setting, we have 5 pointers, list 0, list 1, list 2, 3, and 4, and we're setting each one equal to one of these 5 pointers we already have. And now, that's a C++ syntax. In C, you're supposed to declare all your variables before you do anything. Although many C compilers will let you declare them wherever. So again, it told me that I should have included standard lib.h. And if I run it, then it says hello world from Hank Child. So it goes through each of the 5 words, right? We have, in fact, I could have called this instead of list, I could have called it word list. And so it goes through each of the 5. And in fact, this is exactly what it does when you take command line arguments, argc and carstar argv. This is saying, and it's kind of an unusual syntax that I would not recommend for any setting aside from, actually, I think it will let me do it. Let me just take that away. I think it'll just let me do that. So it's saying argc is the number of arguments and argv is the a pointer to carstar being strings. So this would be a pointer, and each pointer is pointing to a string. Actually, I'm not sure those parentheses really help us understand it. So now we could do the same thing, and instead of iterating over 5, we can iterate everything in argc. And instead of printing the word list, we're going to print argv. So I have some typos, but it still printed them out, every argument that was passed in. And again, it's using this same thing where it is a list of words. And so the first one was a.out. I misspelled hello as hell, world from Han, childs. And so each of those was printed by this statement here. So we have pointers to pointers. In this case, what we're pointing to is we have 5 or so, 5 words, and then we have an array of pointers, and each one of those pointers points to each of those 5 words. So of course it doesn't need any characters, and this gets us directly into the homework. That we can have something like this, and I believe this is straight from the homework, and something like this. And I believe in the homework, let's make sure I'm using the same syntax. Oh, I don't have it listed. I believe in the homework I'm actually doing this with as the syntax, which is B0, whoops, A0, A7, and A14, which is the same as and then saying B0 equals, and in fact I shouldn't have done this, I should have said A plus 7, and A plus 14, which is the same as doing this. So, sorry, I've made a couple mistakes in setting this up, but what I wanted to say was that if you use an initializer for an array like this, it's the same as just having these statements beneath it. So let me just take the initializer out. I think this is what's in 2D, but now when you read it, you know to interpret it as this thing below. And so what this is doing is if we have an integer A, or I'm sorry, an int array A, and it has values, and I think in the homework I have it as the Fibonacci sequence. course, this will no longer compile when I put the dot, 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 but you understand what I'm after. Then when I say b of 1, well, that's a pointer because that's going to resolve to be a plus 7. But if I say b of 1 of 1, well, that would say go to a plus 7. That's what this would give you. And then go 1 forward. So it's doing integer arithmetic, right? So if we were to use our relationships, well, we know b of 1 is a plus 7. And we know that when we do this, it's the equivalent of saying plus 1, which would be the equivalent of a plus 8, which would be the equivalent of a 8. And so B11, we would just go to A8. So here's 0, 1, 2, 3, 4, 5, 6, 7. Looks like 8 would have been, oh, I've missed one here, huh? There's the Fibonacci. Would have been 28. So the other way to look at it is that B1 would go to the 7th spot. So 0, 1, 2, 3, 4, 5, 6, 7. And then it's just a pointer to that location. And then, so then B1 is pointing to this location. So I could say, if I had said int star C equals A plus 7, and then I was evaluating C of 1, that might be a little less confusing to people. Because you'd say, well, this would be the location C right here. And if it was, then if I said, well, C of 1, we'd say, well, C of 1 is 21. It's 1 pass. And the issue here is you've got an extra layer to get there, to say B1, 1. So pointers to pointers get a little tricky. And my advice is to write simple programs. And you can just write a program just like this and test it yourself. You can actually construct the arrays, and I actually intend for you to do this and to be making the print statements that I make and compile it. Look out for compiler warnings because if it's telling you you're printing the wrong type, it's probably because you've thought something is an integer when it's a pointer. But it is my intent that you're going to build up your intuition about arrays to arrays. I think you actually have all the information in the previous slides in terms of pointer arithmetic and dereferencing. But that you'll go with these print statements and figure things out from there. And again, you can print a pointer with %p. So I have one more concept that I wanted to mention, which is there's a special pointer in C called the null pointer. It's often stored as address 0000000, and it's really just used to initialize something as a known value. And so you can say int star a equals null. And what you've done here is you've said, well, a doesn't point to anything valid, but it's also not uninitialized memory. And so you'll often have checks saying, like, if a equals null, well, you know, I need to do something to make a point to valid memory. But if you don't use the null pointer, then what would happen is you'd say, well, if a equals, and then you don't really know what to compare to because it would just be garbage memory. So null gives you a place that you can point to. You say, aha, it's not really pointing anywhere valid, and I need to fix it. So that's the null pointer. Project D, again, write C programs yourself, and it's due Thursday, 10 a.m. in class. We've already printed it out, and you have it. Again, we said 10:01 is late and is no credit, and that's my policy because of previous experiences. And actually, no Piazza posts on this, please, because the intent is that you're going to just work this out yourself with little programs. So again, I have office hours Monday at 10:30. I think it's 10:30, and if not, I will post a correction. and look forward to seeing people then. Okay, hope this worked well as a lecture format. I actually hope to get some feedback from you because I will be gone later in the quarter as well and trying to figure out how to handle that. Thanks, everyone.